I started this project like I do most, with a blank piece of paper and an itch to create something. In a previous video, I made a donation box used for a bake sale at my church and thought a matching serving tray would also be a fun project. I settled on a design where two opposite sides of the tray are convex, the other two are concave, and they meet at the corners, creating this sort of continuous curve around the entire tray. It's 19 inches long by 14 inches wide, with the corners at 2¼ inches high. The highest point on the handles is 2¾ inches. If you're interested in making your own, I've included a link to a file with all of the dimensions. After scribbling my notes, I climbed up the ladder to collect the materials I needed: sapele and maple. I have a lot of sapele from a local shop that I got that's about 2 by 2 and 3 feet long, so this was another chance to use up some of that and provide more credibility to the adage, one man's scrap wood is another man's project. Everything I gathered up was this piece of sapele that was curved at the top I'd used for the sides with handles, another piece for the concave sides, some maple that would be the bottom panel, and plywood used to create templates. So the real work began by breaking down the plywood, taking measurements and marking for the width and height of the side with handles. The most important part of making the template here was marking the height on each end and in the middle so that I could accurately put the curve on the top. I drilled 3 holes at each of these points and put a nail in each hole. Then I took this strip of 1/8 inch thick pine that I cut off a 2x4, bent it around the nails, and traced it to get the appropriate curve. Next, I measured and marked the cutout for the handle. Turns out I don't have a compass, so I made my own out of a thin strip of wood with a couple of holes drilled in it and a nail. And no, I was not watching Alvin and the Chipmunks while doing this. That's just what my daughter sounds like after she's had a cookie. I measured and marked the template for the other side the same way, using a thin strip of wood held in place by nails to form and trace the right curve. After I marked everything on my templates, I cut them to length at the table saw, then cut the curves out at the bandsaw. I then took the template for the side with the handle over to the scroll saw to remove the waste for the handle. The only work remaining on the templates was sanding and final shaping. And I've got this nifty sanding disc for my table saw that I'd never used before, which was pretty cool. The rest of the filing and sanding was a little bit less enjoyable though. I used the template and marked the length that I'd need plus some extra and moved over to the table saw to begin cross-cutting this guy. It took several passes because it was just over 3 inches thick. I gave it a couple of passes at the joiner to flatten the first face, adjusted the depth of my planer, and then a couple of passes there for the other face. I took it back to the jointer for the third side before heading over to the bandsaw. I resawed 2 pieces from this curved fella at 5/8 of an inch thick for the concave sides with the handles, and 2 more pieces from my other board, also at 5/8 of an inch thick, for the convex sides. Next, these were all planed down to their final thickness of 1/2 inch. I used a couple pieces of double-sided tape to stick the template to my work pieces so that I could cut out the rough shape of the curved side. The kids came outside to play for a little bit, and they aren't big fans of the loud machines, so to appease them I did a lot of sanding by hand to refine the shape. When they went back to the indoor playground, also known as the living room, I went back to the loud machines. And I roughed out the concave sides just like I did previously, with double-sided tape. Next up was working on the handles, so I drilled a few holes here and removed all of the waste for the handles at the scroll saw. I had just a little more filing and sanding to do before moving on. No, that's a lie. There's actually a lot of sanding and filing. and sanding and filing. It was finally time to cut the miners on all the sides, so I squeaked over to 45 degrees and got after it. Now this was tricky because I had already cut the shape of all the side pieces. So I made the first cut with the bottom of the flat edge against the miter fence. Then I flipped the pieces around to cut the other miter, but I had the curved top against the miter fence. I didn't come up with a neat or scientific way to measure or hold everything in place other than just eyeballing it. But I just had the prescription of my glasses updated, so what could be more accurate than that? Next, I set my rep fence and cut dados a 1/4 inch wide on all 4 sides that would then accept the bottom panel. I had 3 pieces of maple to be milled up for the panel, first cross-cutting at the table saw, over to the jointer, then planer, and then squaring up the last edge back at the table saw. I resawed my 3 maple pieces to 1/2 inch, leaving 1/8 of an inch more than I needed. From each of my 3 maple friends I got 2 pieces, 1/2 inch thick and 1/4 inch thick. I set the middle pieces to the side and then labeled the others. They were also all different widths, so to make the panel symmetrical I took a piece of sapele to be the middle and then put one of my A, B, and C boards on each side. This will make more sense in a second. I planed everybody to their final thickness of 3/8 of an inch and then it was time for glue. I set up my clamps and one by one I put glue on each edge and slid into place all 7 boards that made up the panel. Each of my maple pieces are sort of book matched on either side of the sapele in the middle here. I added some cauls, tightened up everything, and waited. Once the glue dried, I thoroughly enjoyed scraping it all off, and I sent the panel through the planer, which barely fit, and my planer is 15 inches wide. Then I cut it to its final dimensions. I cut a 1/4 inch wide rabbet in the panel with my dado blade that would fit into the dado cut into all the side pieces previously. I had to refine the width of the panel with the hand plane, and then shaved a little bit more off the rabbet to get the panel to fit just right. Using a 3/8 inch roundover bit, I softened the inside of the handles and did a little bit of scraping and sanding before gluing everything together. With all my sides laid out in the correct orientation, I proceeded to use the blue tape method because I don't have any band clamps. All the sides laid out end to end were over 4 feet long, so this part was kind of fun since my little table here is definitely not 4 feet wide. It worked out okay though, as you can see I got everything to align properly. Naturally, the only place to do this glue up was the longest, kinda-ish flat surface I have, the kitchen table. So I spread some glue into each of the corners, folded it up, and slid the panel into place. I added some more blue tape for good measure and scraped out any of the glue with the plastic straw. The curvature of the sides made it so that the inside of the corners didn't align even though the outside did, so I cleaned these up with a chisel after the glue dried. And there's nothing a little glue and sawdust can't fix. With all that cleanup work done, I started cutting slots for my splines. I cut the one on the top a little closer to the edge than I intended to, but everything still looks okay. I cut all my splines, dabbed some glue onto each, and shoved them all into their slots. This next part could have worked out a little better. I didn't pay attention to the grain direction of the splines and put them in with the end grain facing out, so planing them went pretty slowly. A quick hit with some 220 sandpaper and knocking down the edges was all that was left prior to applying finish. I used Howard's Butcher Block conditioner for the finish because I might end up using the serving tray for food to be put on, so I wanted to use something that was food safe. The finish really accentuates the grain direction on the sides where it follows the shape of the curve, which looks pretty cool.